Okay, let's try this again, make it a bit cleaner. So, we're doing calculations with masses today. So, number one, try and squeeze it in. So, it says 10 grams of calcium carbonate was heated. The mass of calcium oxide left over was 5.6. Now, this one is a very simple conservation of mass question. What it is telling us is that 10 grams on one side will make 5.6 plus another amount of grams there. Okay, now remember, there's got to be 10 grams on both sides. So all you need to do is take 5.6 from 10, okay, do 10 minus 5.6. That gives us 4.4. Therefore, this value here, the amount of carbon, the mass of carbon dioxide produced in the reaction is 4.4. Right. The next one says, copper oxide is reduced by excess hydrogen. Calculate the maximum mass of copper that could be obtained from 79.5 grams of copper oxide. So we have copper oxide becoming copper. Now it's only asked us about these two. You don't need to worry about the other things in the equation, the H and the water. You can ignore those because it's given us the mass of copper oxide and it's asking us about copper. Now, the first thing we need to do is work out the MR of these two things. Now, the MR of copper oxide is 63.5 plus 16. Now, that is 79.5. Now, this will make 63.5. Now, what this is saying is 79.5 grams of copper oxide will make 63.5 grams of copper. I don't now need to fiddle about with reducing the numbers down to make 1 and then multiplying back up, because we have inadvertently here answered the question by working out the MR. So in fact you would make 63.5 grams of copper by starting with 79.5 grams of copper oxide. Good. Number 3. Here we have calculate the maximum mass of carbon dioxide that could be obtained by adding excess hydrochloric acid to 15 grams of calcium carbonate. So first of all, we will go with calcium carbonate and we are looking for the CO2. We don't need to worry about any of the other things in the equation. They are not important. Now, CO2 is 16 times 2 for the oxygen plus 12. That makes 44, my calculator says. And then we will do calcium carbonate, so 16 times 3 for the oxygens, plus 12 for the carbon, plus 40 for the calcium, gives us an MR of calcium carbonate of 100. Now, what this is telling us is that 100 grams of that will make 44 grams of that. That's what that's telling us. Now, we need to find how much 1 gram of calcium carbonate would make, because that's the value we're given. Okay, so to find out how much 1 gram, I simply divide that by 100, and that will tell me how much 1 gram makes. Okay, so I also then need to divide 44 by 100, and that makes 0.44 grams. What this is saying is, therefore, is that 1 gram of calcium carbonate will make 0.44 grams of carbon dioxide, and therefore, if I then just multiply both those values by 15, it will tell us, so I'm going to times both of those by 15, it will tell us that 15 grams of calcium carbonate will make 6.6 grams of carbon dioxide. Okay, there we go. Let's roll on. So number 4 is talking about the maximum mass of ammonia, NH3, that can be made from 42 tons of nitrogen and excess amount of hydrogen. So lots of hydrogen, don't need to worry about that. Now this is in tons, but actually your values don't matter. You start off with 42 tons of nitrogen. It just means you'll end up with some tons of ammonia. Start with grams, end up with grams. Start with tons, end with tons. It doesn't matter. You'll still get the same thing. So we need to say that N2 will become, and this is where it gets tricky because we've got balancing numbers to work on now, 2NH3. Okay, so N2 we've got 28 MR and NH3 we've got 17. So this is telling us that 28, hang on, we've got tons here, and with 28 tons of N2 will make, now obviously this is 2 NH3s, so it's 7, so it's 34, okay, because we've got one of these makes 2 ammonias. So 28 tons of N2 will make 2 times 17, 34 tons of ammonia. Now, we are trying again to find out how much can be made from nitrogen. So we need to make nitrogen here. We need to make this one 1 gram. So to do that, I need to divide them both by 28. Slowly run out of space here. I need to divide them both by 28. Okay, 1 ton, sorry. So this then is 1 ton. And 34 divided by 28 is 1.21429. There's loads of decimal places there. Tons, okay. What I then need to do, let me shuffle this down a bit. What I then need to do is multiply them both by 42 to give me my final answer. Now I can just leave the full-on calculator value in my calculator, and that is, okay, so 42 tons of this basically gives you 51 tons of ammonia. Now I know you're going to say, hang on a second, okay, hang on a second, you've got a lot of zeros there, but there's so many zeros, we'll just ignore that. Please note, this example is actually explained over here as well, so that's nice. Now, let's get cracking then on number 5. So number 5 tells us, okay, calculate the maximum mass of ammonia needed to produce 396 kilograms of ammonium sulfate. So what that means is, so we've got this is question 5, isn't it? We've got 2 NH3 going to 1 NH4 to SO4. So let's start off with the formula masses, the MRs again, so that's 17. Now this one obviously gets a bit trickier. So we've got 16 times 4 for the oxygens, plus 32 for the sulfur. So that's the sulfur tetroxide bit, the SO4. We've then got 2 of everything in that bracket, which means we've got 2 times 14 plus 8, because obviously there's 2 times 4 hydrogens, 8 hydrogens. Now that gives me a value, my calculator says, of 132. Okay, now just like before, we've got 2 NH3s becoming one of these, so that is telling us that 28 grams of ammonia will make 132 grams. Hang on, this one's in kilograms, isn't it? Again, it doesn't matter. Doesn't matter. Kilograms. 28 kilograms of this will make 132 kilograms of that. Okay, now we need to find out how much ammonia over here is needed to produce 396 kilograms of ammonium sulfate. So we need to turn this one into 1. So we need to divide this by 132 to find 1 kilogram. And therefore we need to divide this one as well by 132. Now 28 divided by 132 is lots of 0.21 essentially. Okay, there's lots of 2121s there. I'm going to leave that value in my calculator to use later. So 0.21 essentially kilograms of this will make 1 kilogram of that, but I need to know how much of this we need to start with to make 396 kilograms of that. So I'm going to times them both by 396. Okay, and that will tell us that to make 396 kilograms of ammonium sulfate times 396, I need basically, again, let's round up, 84 kilograms of ammonia. Okay, doing well so far, guys. Now, 6 says 250 centimeters cubed of a solution of copper sulfate containing 5 grams of dissolved solid. Calculate the concentration of the solution in grams per decimeter cubed. Now, for this, we need C equals M over V. Okay, we've got to remember as well, though, that V has to be in decimeters cubed. So the first thing we need to do, you can do all this in the formula if you like, is we need to do 250 divided by 1,000 to change the centimeters cubed over here into decimeters cubed. Now this means essentially we've got C equals 5, because 5 grams is our dissolved solid, divided by 0.25, which is our volume in decimeters cubed. So 5 divided by 0.25 is 20. Okay, so that means we have 20 grams per decimeter cubed. Okay, or if you want to write it, 20 grams per dm to the minus 3, that is equally acceptable. That's the same essentially. Well, that minus 3 is telling you that it's over dm cubed. Right, there we are. Now the last one we have, I've run out of space, is we have 7. Let's have a cheeky look. What I'll do is I'll slap him over here. We'll have a cheeky look at 7 before we finish, because there we are. So 7, let's go for 7. So it says calculate the maximum mass of aluminium chloride that could be produced from 6.39 grams of chlorine and excess aluminium. So here we have 3Cl2 becomes 2AlCl3. Okay, so we've got two different balancing numbers here. But again, we still have to worry about working this out. So chlorine, I'll have a cheeky little check, but chlorine is 35.5. Now what that means is, chlorine is 35.5, that means Cl2 would be 71, okay? So the MR of Cl2 is 71, okay? And AlCl3 is 35.5 times 3 plus the AR of aluminium, which is 27, giving me 100, an MR here of 133.5. Okay, so those are the MRs of our two compounds. Now, we now need to accept that, remember, that 3 71s will make two 133.5s. So we need to times 71 by 3. That will give us 213 grams. This is in grams, that's fine. We'll make 133.5 times 2, 267 grams of that. That's what that's telling us. So 213 grams of chlorine will make 267 grams of aluminium chloride. Okay, now again, we need to be able to deal with the chlorine. We need to be able to turn chlorine into 6.39. So we need to turn the chlorine into 1. So we need to divide that by 213. So we are going to divide them both by 213. And what that means is, that will tell us that 1 gram of that makes 267 divided by 213 makes 1.254 grams of this. Now I got a much longer number on my calculator. I'll leave it in there just for completeness and I can deal with that later. Now we are then going to multiply by 6.39, and what that means is that will tell us how much 6.39 grams of chlorine produces. Okay, so I'm going to multiply this by 6.39, and that will tell us that basically it is 8.01 grams. There we go. Fantastic, guys. There is a sheet dealt with. That is CC9B.2. Thank you very much for watching, guys.